A neutron star has mass 5.2 times 10 to the power of 30 kg and radius 1.7 times 10 to the power of 4 meters. Calculate the mean density of the star. Density is given by mass per unit volume. Substituting values, we have density to be 2.53 times 10 to the power of 17 kilogram per meter cube. Suggest with a reason whether the density is likely to vary with the distance from the center of the star. Now, the outer layers of the neutron star are likely to experience large gravitational forces such that it exerts extreme pressures on the inner layers. Hence, the density is likely to increase from the outer to the inner layers of the star. So it's the same as the water in the ocean. The water deep below will have a higher pressure, and therefore the density will be higher because for the same mass, the volume will be smaller. The mass of the star may be considered to be a point mass at its center. Calculate the gravitational field strength at the surface of the star. So gravitational field strength equal to Gm over r square. Substituting values, we have G equal to 1.2 times 10 to the power of 12 Newton per kg. So the units is the same as meter per second square. Determine the centripetal acceleration of a particle moving in a circular path of radius 1.7 times 10 to the power of 4 meters and with a period of rotation of 0.21 seconds. Okay, for such a particle, acceleration is equal to r omega square. Omega is 2 pi over period. So we have the acceleration to be 1.52 times 10 to the power 7 meter per second square. The star rotates about axis with a period of 0.21 seconds. Okay, use your answer in 1 and 2 to suggest whether particles on the surface of the star leave the surface owing to the high speed of rotation of the star. So G is 1.2 times 10 to the power of 12. A is 1.52 times 10 to the power of 7. So obviously G is much larger than the acceleration, the centripetal acceleration. Since the gravitational field strength is larger than the centripetal acceleration, a particle at the surface will experience a normal reaction, and such that the resultant force mg minus n equal to ma, and this a is a centripetal acceleration. So the normal reaction force will be greater than 0. Now n is the upward force by the surface on the particle. Based on Newton's third law, there is a force n prime, which is downward. It's a force acting by the particle on the surface. That means the particle is pushing down on the surface. Or we can say that the particle is held onto the surface by a force of magnitude n, which is equal to the magnitude of n prime. Therefore, the particle will not leave the surface.